Okay, let's unpack this. You've probably seen the headlines swirling around lately, maybe the social media debate. It was triggered by an Apple research paper that got a lot of attention.
Yeah, outlets like The Guardian covered it pretty widely.
And the viral claim was basically that these large language models,
Yeah.
think ChatGPT, Claude, Gemini, all those ones, they don't actually reason.
Right, that it's more like a sophisticated illusion of thinking, just predicting patterns based on, well, the mountains of text they were trained on.
It really did spark a massive conversation, didn't it? And often that core message got kind of simplified right down.
Oh, definitely. To something like, LLMs fail at complex reasoning. Therefore, true AGI, artificial general intelligence, is probably way off, maybe even overhyped.
And that really sets the stage for our deep dive today. We're taking the source material you shared specifically, an article that really digs into this whole viral claim and goes back to look closely at the original Apple paper itself, the 30-page one.
Yeah, the goal is to figure out what's actually going on here. What's the reality behind those headlines that grab your attention?
Exactly. Our mission for you, listening in, is to move beyond those extremes. Not getting swept up in the hype or the really deep skepticism.
We want you to walk away with a clearer, much more nuanced understanding. What these models are fundamentally capable of, what their real limitations are, and maybe how to cut through the noise a bit better.
Okay, so let's start with that central idea. The Apple paper and the media storm that followed. The argument was that when LLMs face these complex reasoning puzzles, they just fall apart.
Mm-hmm. They might handle a simple version okay, but add a few layers of difficulty.
And boom, performance drops off a cliff.
Right. The paper used some classic logic puzzles. Things like the Tower of Hanoi, some checkers-based challenges, and those river crossing problems.
Oh yeah, the fox, chicken, and grain one. Everyone knows that.
Exactly that kind of thing. And the authors showed the models did pretty poorly as these got more complex. They argued this failure, well, it demonstrated a lack of genuine algorithmic reasoning ability.
And this is where the source article we're looking at comes in. It points out how quickly that finding got twisted into those headlines. Often really problematic ones.
Creating this wild pendulum swing in how people see AI.
1 minute, AI is this unstoppable job-killing super genius. The next, it's just smoke and mirrors, completely fake.
And that kind of extreme framing, the article argues, really stems from a fundamental misunderstanding of what these models even are. It just prioritizes viral drama over, the actual complex reality.
Because the source article's first big counterpoint kind of gets right to the heart of it. It says these limitations, they aren't actually new discoveries.
Exactly. And maybe more importantly, it says people are making a mistake by expecting LLMs to behave like, traditional computers or calculators. LLMs were never really designed to be deterministic, step-by-step algorithmic machines in their core function. They are, at their heart, probabilistic neural networks.
Probabilistic. Okay, what does that actually mean in practice?
Well, think of them as incredibly sophisticated pattern-matching prediction engines. They analyze just vast amounts of text, learn the statistical links between words, concepts, and they predict the most likely sequence of words that should come next. It's not about following rigid logical instructions, it's about statistical likelihood.
So their thinking isn't like following a recipe step by step, it's more like predicting the ingredient most likely to follow the last one, based on all the recipes they've seen.
That's a pretty good analogy, actually. And the source article uses a really simple example to drive this home: multiplication.
Yeah.
You ask an LLM to multiply two really big numbers just on its own without giving it any other tools, it'll almost certainly fail.
Yeah, and the headlines might jump on that, right? AI can't even do third-grade math.
Yeah.
That kind of thing.
But the source article says, well, that's exactly what you should expect. It's not designed to run a multiplication algorithm internally like a calculator does.
Its strength is in predicting plausible text.
Precisely. Based on patterns. Asking it to do complex arithmetic without tools is, like asking a poet to calculate pi to 1,000,000 decimal places in their head. It's just the wrong tool for that specific job.
Okay. And this is where it gets really interesting, I think. Because the source article highlights how that whole picture changes the moment you introduce tools.
Absolutely. This is critical. The article argues that the very same models that might fail at raw multiplication or those logic puzzles on their own suddenly they can succeed brilliantly.
When they're allowed to use external tools.
Exactly.
Tools like, what are we talking about?
Like a code interpreter, for instance. The source article gives this great example. Claude Opus, one of the big models, failed a complex math equation when asked to solve it directly.
Okay,
But when it was allowed to write and then run some code to figure it out,
got it right.
perfectly right. So it's not just predicting text anymore. It's leveraging an external deterministic capability, a tool.
So it's not that the model suddenly became a calculator inside its head. It just knew how to use a calculator when you gave it one. That feels like a really critical distinction. It gets lost a lot, I think.
It really does. And speaking of things getting misunderstood, the source article also touches on hallucinations.
Ah, yes, the dreaded hallucinations.
Right. It acknowledges, yeah, models do hallucinate. They confidently state incorrect information. That sounds very plausible. But again, it links this straight back to their probabilistic nature.
Because they're designed to generate the most probable next word or token.
Not necessarily the truthful one, unless, and this is key, unless they're specifically integrated with something like a fact-checking database or a search tool.
Right.
And it's worth remembering, humans also hallucinate. We confidently state falsehoods sometimes, too. The mechanism is different, obviously, but the phenomenon isn't unique to AI.
Good point. Okay, so we've got the original claim, the probabilistic nature, why they fail at raw math, but how tools change the game. Now, let's dig into the source article's critique of the Apple paper's methodology, because it points out some specific issues.
Yeah, reasons why those conclusions might be, let's say, questioned. A major point the article raises is about token limitations.
Token limits, like how much text they can process or generate at once.
Exactly. It suggests the Apple paper tested models on puzzles that required output sequences, the step-by-step solution for a complex Tower of Hanoi, for example, that were simply too long. Too long for the model's built-in context window or token limit at the time.
Ah.
Think of it like it's working memory, or maybe the size of the notebook page it has to write the answer on. Claude, for instance, had a 128K limit back then.
So they were essentially being asked to write out a solution that just wouldn't fit on the page they were given.
Pretty much. And what's fascinating, as the source article points out, is how the models behaved when they hit this limit. They didn't just output garbled nonsense.
No. What did they do?
Often they did something quite rational within those constraints. They might give a shorter summary-like answer, or even suggest using an algorithm or an external tool to solve it. Basically saying, look, I know how to approach this, but I can't write the whole thing out right here.
That sounds less like a failure of reasoning and more like, a failure of output buffer size. It's like saying a human is bad at reasoning because they can't verbally recite every single digit of pi.
It's a very different kind of constraint, isn't it? And the source article also raises this eyebrow-raising possibility of a biased study design.
Biased how?
Well, it suggests the Apple authors might have initially been comparing, say, thinking versus non-thinking models on math tasks. And when the models that could use or suggest tools performed better on math than maybe expected, the suggestion is they might have pivoted. Switched to logic puzzles specifically to find results that better supported their initial thesis that LLMs lack that fundamental internal reasoning.
Wow, okay. That's a pretty strong suggestion about the study's origins.
It is, yeah. Based on the article's interpretation of how things unfolded, and apparently the critique didn't stop there, the source article mentions a response paper came out.
Okay.
Co-authored by a researcher who actually worked with Claude Opus itself, reportedly. And this response paper pointed out logical impossibilities or inconsistencies within the very structure of the Apple study's prompts or its setup.
Seriously? So problems with the test itself.
That seems to be the claim, further casting doubt on the findings.
So this whole idea that LLMs had suddenly hit some brand new, never-before-seen fundamental barrier in reasoning, the Apple paper seemed to imply that.
Yeah, but the source article suggests that's not quite right. Similar observations about these kinds of limitations, especially without tools, were already pretty well known. People were discussing them back in 2023.
So it wasn't some earth-shattering revelation for the AI research community itself?
Probably not. More like it reinforced existing understandings of the model's capabilities and, importantly, their limitations when used in certain ways.
Which brings us to how this all lines up with, real-world benchmarks, how these models actually perform in practice beyond these specific puzzle tests. The source article brings up models like OpenAI's GPT-4003 Pro.
Right. It points out that model, which, at the time was pretty pricey, around $200 a month, shows very strong performance on standard academic and coding benchmarks.
Like what kind of scores?
We're talking things like 93% on advanced math problems, 84% on PhD-level science questions, scoring highly on competitive coding challenges. Pretty impressive stuff.
Those do sound impressive. But the source article also adds some crucial caveats about benchmarks, doesn't it? You can't just take them at face value.
Oh, absolutely not. That's key. Companies can, and let's be honest, often do, cherry-pick the results that look best.
Right.
They might hide how many attempts it took to get that good score, for instance. So it's really essential to look at performance across different vendors, Anthropic, OpenAI, Google, you name it.
Compare.
Yeah, compare results across multiple independent benchmarks. Don't just rely on one company's flashy press release numbers.
That's really practical advice for anyone trying to figure out how good these things really are. So, okay, let's pull all this together. What are the most important takeaways from this source material for you, our listener?
Well, the first fundamental point, reinforced throughout the article, is that LLMs are not calculators. They're not deterministic logic engines in their basic design.
Right, expecting them to behave like one just leads to misunderstanding when they fail.
Exactly. Their core design isn't about strict algorithmic execution. It's about predicting patterns and generating plausible text.
Okay, so what are their actual strengths then, according to the article?
Their true strengths, it suggests, lie in pattern recognition across just massive data sets, creative generation, and critically, their adaptability when they are integrated with external tools.
Pattern recognition, generation, tool use. That's the actual superpower triad, kind of.
You could put it that way. And the hallucinations we talked about. They are, in a way, a natural feature of that probabilistic design. They generate the most likely token, not necessarily the truthful one, unless they have tools to check.
So it's not necessarily a sign they lack intelligence entirely?
No, just that their error mode is different from what we expect from, say, a traditional computer program.
And maybe the central point, the most important one from the source article, is that the real moments of enhanced reasoning, those breakthroughs where they tackle complex problems effectively,
Yeah.
they happen not when the model's trying to do it all internally, but when it's integrated with those external tools. Code runners, symbolic logic systems, databases, whatever.
That integration is absolutely key. It lets them combine their probabilistic pattern matching, which they're great at, with the deterministic power of traditional computing tools.
Okay, so based on this whole deep dive into the article critiquing that Apple paper, what's some practical advice for anyone using or evaluating these LLMs?
Right, some takeaways for you. First, if you're currently only interacting with the free versions of models, the article suggests maybe considering trying out the paid tiers. Things like GPT-4o, O3 Pro, or Claude Opus.
Why?
Because they often have better underlying capabilities and, crucially, better integration with those tools we just talked about. That's where a lot of the real power comes in.
Gotcha. So the free versions might not be showing you the full picture of what the system can do when it's allowed to use its strengths effectively.
Exactly. Second piece of advice. Always evaluate models based on your specific use case.
Right, not just the general hype.
Precisely. Benchmarks give you a general sense, sure, but how well a model performs on your task, whether that's writing code for you, drafting emails, brainstorming ideas, whatever it is, that's what truly matters.
Good point. Don't get fixated on one benchmark score if it's not really relevant to what you actually need the AI for.
And finally, maybe most importantly, be highly skeptical of those headlines, the ones that jump wildly between extremes, AI is everything or AI is nothing.
Yeah, the pendulum swing.
The truth, as we've kind of explored through this source, is just much more nuanced. And that nuance about strengths, limitations, the critical role of tools, it's pretty well understood by most serious researchers in the field already.
That feels like a much more grounded perspective. We've gone from that viral claim about LLMs just creating an illusion of thinking to understanding, okay, they're probabilistic systems, they have specific strengths. Those strengths get dramatically enhanced when they use tools. And some of the critiques might have been based on testing them outside their core design principles or limits.
It really highlights that the path forward for AI, it isn't just about making bigger and bigger language models in isolation. It's probably more about building smarter systems, systems that intelligently combine different capabilities.
Which leaves us with a final provocative thought for you, our listener, to consider.
Yeah.
If integrating large language models with external tools really does unlock entirely new levels of capability, new ways of problem solving,
Yep.
what previously unsolvable challenges may be in your field or areas you're interested in, what might suddenly become tractable with this kind of integrated approach?
Something to mull over as you encounter the next wave of AI news and developments, definitely.
Thank you for joining us for this deep dive into the truth behind those AI reasoning headlines.
Yeah, we appreciate you exploring these sources and ideas with us today.